Hello everyone, this is Karan Kumar Yogya and you are watching the Fluxray Electronics. In today's video, we are discussing the remaining part of our HDL Bits solution series. So in previous video, we are covering the basic and vector topics. So in this video, we are discussing the modules hierarchy topic. So let's get started without wasting any time. So our first question is like from the module. The question is like we have one mod A named module and one another module called as top module. So we have to instantiate mod A inside the top module. So there are signals of top modules are A and B, which is connected to in one of the mod A and in two of mod A. So out is connected to out. Okay. So we have to instantiate this mod A inside this top module. So let's get started. So first, we have to instantiate. Okay, instantiating the mod underscore a. So for instantiating, what we have to do? So first, whatever the name of the model. So mod underscore a. So we have to give the name of instance. So instance name can be like anything, but it's always a good practice to give a name which is related to our module. So here we are like giving the name as like instance, like inst underscore model. Okay. So it's the relatable name. Okay. So what we have to do, connect this. Okay. So there are like connecting, there are like three different types, like by name, by position, and by default. Okay. So it is always better or like good practice in industry. So we are connect like by connecting by the name. So let's do it by name. So here, if you see that A is so in one is connect with the A, in two is connect with the B, out is connect with the out. Okay. So in parentheses, give the semicolon. Okay. So dot in one. So in one is connect with the signal A. So in uh, by name connecting first whatever the like instance we are creating that signal came first. After that, where we create the instance, that signals came in parentheses. Okay, comma. So again, dot into. Okay, so into is connect with the signal P. After that, out is connect with the signal out. Okay, so out is connect with the out. So this is the solution for this question. So let's run it and check it it's working or not. So there's the submit button. So it's executing. Okay, we get the status success. Okay, let's move to the next question. I already solved this question, but I forget to record that sessions. So again, let's complete it. So this problem similar to the like modules. Module means like this. First question is similar to that. So here one top modules are there and one model. Okay. So we have to instantiate mod underscore a in top module. So here like four signals are there. Okay. So let's read the question. In order you must connect six port by position. So in previous question we are doing done with the name. So here we have to connect with the position. Okay. So let's go and do that thing. So when we are like doing the connection, so you have to think about the like whatever the model you are instantiating, the order. So here the order is like first to our outputs and then inputs. Okay. So in that way, we have to connect. So if the input are like first, then you have to connect first input, then output. Okay. So let's move on to like instantiation. So mod underscore a. So first the name of the model which we are instantiating. Then the name of the instance. So inst underscore a. Then we have to parenthesis. In parenthesis, if we are like connecting by position, so we don't mention the mod A signals. We directly mention the signals of the top model, like where we instance. So first, as here they are like providing. So first two are the outputs and then four inputs. Okay. So what are the output signals? Out one and out two. So let's write first out one, out two. Okay. After that, four inputs we have to mention. Like these four inputs we have to connect. Okay. So we are writing the four inputs. What are the inputs? A, B, C, and D. Okay. Okay. Let's submit and check it it's working or not. Okay. So for the example, we are like doing by position, but position never we are using in industry. So status success, we get it. Okay. So if we are like doing by the name, so in that case, so we have to connect that. You have to know the name of in one, in two, in three. So signal in is not like not this is like wrong declaration of mode at that time. Okay. So let's move to our next question. So our next question is a model name. So the problem is similar to the model. So similar to first question. So has two outputs and four inputs in same order. You must connect the six ports by the name to your top model ports. Okay. So this is our top model. We have to connect this by the name. Okay. It's the same the question like previous one, but the thing is like here that there is like by uh, position we are doing here by name we are doing connections. Okay. So first, like in one is connect with the A. Okay. So first the name of the like whatever we are instantiating. So we are instantiating mod A. So let's write the mod underscore A. Okay. So after that, what the instance name? Inst underscore A. Okay. This is the instance name. You can give your name, like some another name, anything. Name can be like anything. So by name we are doing. So for that first dot we have to write. So in one is connecting with the A. So first what we are writing, the in one is connecting with A and give the comma. Okay. So after that, in two is connect with the B. Again comma dot in three is connect with the C. Again in four is connect with the D. So these are the inputs. Four inputs is connect with the four inputs. Okay. So two output we have to connect. Okay. So dot out one is connect with the out one. Then comma dot out two is connect with the out two. So let's write the out two. Okay. In last we don't require the comma. Okay. So when you're writing that like in single row you can write it, but when you're writing in that column wise manner, it's easy to like debug or see the connections. Or when you are going to verification time at that time, it's easy to like copy paste like multiple times you are not writing the same signal again and again. So you just like copy paste in that way. So when you are using GVI, at that time it's easy for you. So let's submit and check if it's working or not. It's compiling. Yeah, we get the status success. Okay. So let's move our next question. So our next question is the three modules. So module shift. Okay. So here is like a D flip flop are there. So there are like single D flip flop instantiated three times in top module. Okay. So let's do it. In first flip flop we have to connect with the D. Okay. Some there are like miscellaneous wires. Okay. There are like two miscellaneous wires which we have to I guess declare. Let's see the structure. Okay, we have to declare here. They are not mentioned the like already wires. So here like this wire and this wire we have to mention. We don't require this wire mentioned because this like common clock is like connecting to each of the flip flops. So let's instantiate. Before instantiation we have to declare the wires. And let's declare the wires. So wire. So for this one wire W1, for this signal W2. Okay. So W1 and W2. So after that instantiation. Okay. And first instantiation and then wire declaration, it's giving you errors. So first you have to declare wires and then instantiate. Okay. So here clock, like in every block, clock is common. So first the name of the uh like module which we are instantiating. So here my DFF is the name of the module which we are instantiating. So my underscore D flip flop. Okay. Instant name. Okay, here the three are the instance. So for the relevance and understanding, we are like giving the name as like inst underscore one D flip flop. Okay, you can do like your choice name or like whatever the convenient for you. You can give in that way. So we have one parenthesis and semicolon. So inside by the name we are connecting. So dot clock is connect with the clock. Okay. Then after that, D is connect with the D. Okay. The D is connect with the D. After that, this Q is connect with the this W1. This is whatever we are declared here. So we are connecting. This is our W1 and this is W2. Okay. So this Q is connect with the W1. Okay. So dot Q is connect with the W1. Okay. So this is the connection. So here like three times I'm not writing again and again. So what we have to do is copy and paste for the two times more. Okay. So the name of instance cannot be the same. Okay. So okay. So this name can't be same. The first name can be the same, but this name can't be same. Okay. So here we are writing the second instance. So two here the third instance three. Okay. In that way. So for every flip flop the clock is common. So we don't require to change this column. Here, the second D. Okay. So this D is connect with the W1. So here is W1, which is not like able to see. We are currently not able to see because they are not declared. This is like our declaration. Okay. So this D is connect with the W1. So writing the W1. Okay. And this Q is connect with the W2. Okay. So this Q is connect with the W2. After that, the third instruction. In third instantiation, D is connect with the W2 and Q is connect with the Q. Okay. So D is connect with the W2 and Q is connect with the Q. Okay. So That's it for this question. So let's submit and check if it's working or not, or it's giving any errors or not. So it's compiling. One thing that you should aware of the quarters method. If sometime if you get in error, so you are able to solve that. Okay. So we create the status success. So here like both like quarters and models in messages are like there, like log files are there like showing. So this is like log file. So you are able to solve that things. So let's move to next question. Our next question is the model shift 8. Okay. So this is the similar to like the previous question of my DFF 8. Okay, same thing, but one mux is added. And one more thing is that the D signal size is 8 bit. Okay. So whatever the wire, like here one wire required, here one wire required, here one more wire required, or okay, there is no okay, three different wires we are required for the like each instance output, and okay, output of mux is directly connected to Q. Okay, so there is no requirement of that, and one selection line is there for the mux. Okay, so first we are declaring the three wires. Okay, so wire, this is 8-bit signal. Okay, so we have to give in the vector format. So first MSB, then LSB, 7 down to 0. Okay, uh, just mistakenly write outside the bracket. So 7 down to 0. Okay, so this is our E signal. So whatever the wires are like W1 should be like 8. You are able to see this like slash and 8 means that 8-bit vector is connecting. Here also 8-bit vector connecting. Here also 8-bit vector connecting. Okay, so that's why we are given in vector format. So W1, comma W2, comma W3. Okay, so these are the signals. Okay. Let's go to the instantiation. So first we are instantiated, then connected to mux. Okay, so instantiation. Okay, instantiation. What we have to do? What's the name of the whatever the instance like we are creating for that which module like we are creating. So here the my DFF my DFF 8. For this module we are creating the instance. So for the name my underscore DFF 8. Okay, the name of the instance is like inst. Let's take the easy one. Inst 1. Okay, so in that use the parenthesis. In parenthesis by the name we are connecting. So clock is connected with the clock. So all clocks are common. So dot clock is connected with the clock. So after that use the one comma. Then D is connected with the D. Okay. So dot D is connected with D. Okay. After that we have to connect our Q. Okay. So there is no signal of the top model here, but we are declare the signals. So W1, W2, W3. So that signal. So Q is connected with the W1. Here the W1. Okay. So Q is connected with the W1. Okay. So DQ. Okay. W1 is connected. So cell is connections. Okay. This is the top model connection. So there is no requirement in the this B flip-flop. Okay. So dot Q. Okay. So let's copy paste like 3 times instance we have. So just copy paste it. Okay. Just change the name of instance. Okay. Every time like remember the instance name should not be same. Okay, so common clock are there. So there is no need to like this clock is connected to this clock is connected to this clock. So all are the common clocks. So there is no need to change in this part. Okay. So after that D is okay. So in second instance D is connected with the W1. In third instance D is connected with the W2. Okay. So let's write it. In second instantiation D is connected with the W1. In third instance D is connected with the W2. Okay. So let's move again. So in second instance Q is connected with the W2. In third instance Q is connected with the W3. Okay. So Q is connected with the W2. Q is connected with the W3 third instance. Okay. So this is the instantiation. So now what we have to do is like implement this mux. Okay. So for this implementing the mux, you can use if else or you can do the case statement. But the easiest way is like ternary operator. Okay. Like implementation of mux. So let's implement this mux. So here the output signal is Q. Okay. So Q equals to, so there are like okay, 0, 1, 2, 3 values are there. So Q equals to 2 tick binary 0, 0. If these statements are true, then we have to connect this D signal as it is. Okay. So then D, or if this is the false, what we have to do? Again check the next condition, which is 2 tick binary 0, 1. Okay. If this statement is like true, then what we have to do? If this statement is true, means 1 is coming. So 1 is connected to W1. Okay. So W1. If this statement is false, okay, like 2 tick, it's not 2 tick binary 0, 1, it's not 2 tick binary 0, 0. So what is our next? So we are checking for the next 2 tick binary 0, sorry, 1, 0. Okay, one thing is like missing that is for like where we are comparing. We are comparing with the cell. Okay, equal to cell, equal to cell. You can write like cell in there, like left hand side, and this value is right hand side. It doesn't affect. It's the same thing only. Equal to cell. Okay. So if this condition is true, then this happen. If this condition is not true, then it's going to next. Okay. So in last condition, if it's like 1, 0, if the cell equal to 1, 0, then we have to do W2 like here. So if the 2 is coming, so it's came from the W2. If the 3 is there, it came from the W3. Okay. So else W3 at the end one semicolon or the termination. Okay. So this is the complete solution for this. Let's submit and check it's working or not. Some errors are coming. Top module line number 16 x equal to. Okay. In line number 16 we have to check it. So there is equal to W1 like somewhere. Where is the equal? Okay. So here we have to like this is the mux now. It's like continuously driving. So we have to use assign. We can't do that like uh if we have to like write this, so we have to write in procedural block. So here we are like writing directly assigning it. Okay. Assigning Q. Okay. Just submit it and let's check it again. Yeah, it's working fine. We get the status success. Okay, let's move to our next question. So next question is the mode. Okay, so the question is there is like 16 bit. Okay, okay, total 32 bit signals are there, A and B. So half is split in add 16 and half is split in another instance of add 16. Okay, and again some and some are like, okay, upper bit is like storing some upper bits. Okay, lower bits are storing lower bits. Okay, so let's go with this. So first, implementing this lower instance, then after that upper instance. Okay, so here we require some, okay, one internals wire we require. Okay, so giving the name as wire as W1. Okay, so first declare that wire W1. Okay, so after that instantiating. Okay, instance we are creating. So instance. So in that instance, what we have to do, the lower. So add 16 is the name of the module. Add 16. Okay. So the giving the name as like instance name as inst underscore low. Okay. So like lower bits are they are like treating. Here the upper bit is like treating. So it's stripping down to zero lower bits, 31 down to 16. Okay. So name should be like making any sense when you are like declaring. So when you are like someone is debugging, so it's easy for that. Or like even you are like reading your code again, so at that time you don't require to like think so much. So this is the inst flow. So 15 down to 0. Okay, so this thing. So by name we are doing that. So like A is connected with the A. Okay, so dot A is connected with the A. But here the thing is that A is connecting, like is like 32-bit signal. Here we have 16-bit signal. Okay, so what we have to do that we have to select given the range of this A. So lower 16 bits we have to select. So let's give the range. So range is like 15 down to 0. Okay. So this A is connected. Okay. After that we have to connect next B. Okay. So dot B is connected with the B. But again same with the vector. We don't have the complete B signal here. Okay. So again, we have to pass vector 15 down to 0. Okay. After that, we have to check for the outputs. Okay. So output is like sum. Okay. The sum is going to lower 15 bit of lower 16 bit of the sum signal. Okay. So let's connect that thing also. Dot sum is connect with the sum but lower bits. So 15 down to 0. Okay. So there are like another two signal of this instance like C in and C out. Okay. C out is connected with the W1, whatever we declare here. Okay. W1. So let's first connect that thing. Dot C out is connect with the C out. Okay. Here is no need of vector. Sorry, not C out. It's connect with the W1. Okay. C out is connect with the W1. So one last signal is there. C in. Okay. So let's see how to declare that. Dot C in is connected with the zero signal. Okay. So for this, we like see that whenever there is fixed signal, we are not assigned to any wire because in RTL there is a rule like when you're realizing any design, so the whatever keeps changing or like dynamic signals that can be the implement. So any fixed value we are not implementing in the RTL. Okay. So directly we are connecting with the 0. Okay. So how to write 1 tick binary 0. Okay. You can directly write 0 also. It's working. So let's write directly 0. Okay. So after that, the instance of the second instance of the add 16. Okay. So well, don't write the again like same thing. Just copying it and just pasting it. Okay. So this add 16 instance higher. Okay. First is like lower we are writing. So now we are writing the higher one. Okay. So dot A. It's same thing is like dot A is connecting with the A signal, but the upper bits 31 down to 16. B is connected with the B, but upper bit 31 down to 16. Sum is connected with the sum, but the upper bit 31 down to 16. Okay. So what we have to change only the values like 31 down to 16. Like it's when you are like solving like any questions. So every time you have to like notice some patterns. Like when you are like declaring signals like 15 down to 0, 16. So when you are like using GVM at that time, it's like easy to encode you. Like it's increase your productivity and reducing some time. Okay. So here is like scene is connected with the W1. This is the W1. Okay. So scene is connected with the W1. So scene is connected with the W1 and C out is the open pin. They're not connected to anywhere. So if they're not connected, so we should not also like connect. Okay. Okay. If you are like going for the RTR, it's every instance should be connected to like sometime, somewhere and somewhere. But for as of now, we are like only solving this question, so we are not connecting anywhere. Okay. So just submit and check it's working or not. So it's compiling. We get this status success. Okay. So let's move on to the next question. So this is our next question. So model FADD. So in this model question, okay, so top model we have, there is like two signal A and B, and one signal like sum, which is 32-bit output, okay. So we have like two instantiation of module at 16, okay. Like same question, okay. Only one thing is there, like they are instantiating one more the module add one inside the add 16. So okay, so we have to implement the add 16. Okay, let's see. Okay, this is the provided model add 16. Okay, so we don't require to create this add 16. Okay, so we have to create that add one, I guess. So this is automatically fetched by their uh, test bench add 16 where they are mentioned. Okay, in that way. So this is like little bit complex. Okay, let me read the question first within your 16 full adder. Okay, okay. So A plus B plus C we have to use for the okay. So this is the definition for the add one. So let's go. Let's implement. Okay. So first the add one we have to implement. Okay. So let's do this thing. So for the addition, what we have to do? Like let's use the concatenation operation. So assign, assign then concatenate. So whatever we like addition, the first the like whatever the carry, it's can at MSB side, whatever the addition at the like other digits are the oh, like sum of that. Okay. So first see out the whatever the logic they given here. Uh, uh, A plus B plus C. Okay. So we have to use this thing only. So just copying this. So C out, and after that C out sum. Okay. So equals to this logic. Okay. unnecessarily copied that A plus B before that F. Okay. So this A plus B plus C is assigning to C out sum. Okay. So whatever the sum. Okay. So this is our uh, add one model. Okay. So now we have to instantiate this add 16. Okay. So this add one is going to add 16, which is the internal part of the HDL bits they are implemented. And we have to instantiate this add 16 in this top module. Okay. So this is top module declaration. So let's go with that. So we have to instantiate add 16 twice. Okay. So add 16, we have to instantiate name as inst1. Okay. After that, parenthesis and semicolon. So by okay, so upper address is going to upper and lower address is going to lower. Okay. So this is the lower address is going here and this is upper address coming here. Okay. So instead of inst1, let's do the lower. Okay. So dot A is connected with the A. Okay. 15 bit A. Okay. So all things are not connecting, only the lower bits are connecting. So A 15 down to 0. Like the previous question, the same question is there. Only the thing is add one, we have to implement extra. Okay. So 15 down to 0, comma. So dot B is connect with the B. Okay. So in square bracket, vector value 15 down to 0. Then comma. So after that AB, you have to connect this C in. Okay. So C in is connected with the 0. So C in is connected with the 0. Dot C in is connect with the 0. Okay. So C out. Okay. So C out is connected to some. Okay. Here we have to declare one wire called as W1. Okay. So let's declare one wire first. So wire W1 we are like declaring here. Okay. So C out is connected with the wire W1. Okay. So this is the connection for the lower ins. Okay. So this is the lower ins. So for the upper ins, let's go. Okay. One thing is remaining, that sum. Okay. Sum signal is remaining. It's comma dot sum. Okay. Same sum is we have to connect sum 15 down to 0. Okay. So instead of writing all that thing again, just copying and just paste it. So first we have to change the name of the instrument. Okay, so just HID, I just okay, so I just become somewhere else. So HIG, okay, this should be like an instant name like implement that. It's the higher add 60 implement instantiation. So dot A is connected with the 31 down to 16. Okay, so 31 down to 16. So whatever like wherever the pin is there, so we have to replace with 31 down to 16 again. So here seeing, okay, let's check like whatever we have to put there later. First complete that 31 down to 16. Okay. So this thing we have completed. So let's see C in and C out connection. Okay. So for this C in is connected with the W1. Okay. So earlier we like connected C out with the W1. This W1 is connected to C in. Okay. So C out they are like ignored. Okay. So just ignore that signal. Okay. C out they ignore. Just remove this signal. Okay. So C in is connected with the W1. Okay. So write the W1. Okay. So that's it for this question. So they're like uh, top module are there. Add one we had created, which is instantiated inside this add 16 internally. So we don't need to uh, like create that add 16 model. Okay. So let's submit and check it's working or not. So this is warnings are there. Hierarchy have connectivity warnings. Okay, that warning came due to we are not connected that see out. We are just ignored. That's why that warning come. So you can like declare any empty signal and connect to that. Okay. So we get the status success. Okay, let's move over next question. So our next question is module CS CSE LAD. Okay. So I guess what is the question? Okay, so there are like three add 16 instance are there, one marks are there. So in this question we have to like this top model we have signal A and B which is 32-bit each and some also 32-bit. Okay, so we have like three instantiation of add 16. Okay, and one mux we have to implement. Okay, so the mux select line is 3 out of the add 16 instance. Okay, so this is the lower bit. Okay, it's going to here, and the upper bit is like splitted in this. Okay, so let's implement this. Okay, this is the instance one, instance two, instance three. Okay, we are giving the name in that way. This is instance one, this is instance two, this is instance three. Okay, so let's solve this question. So first write for the instance one. Okay, so we require some, I guess, this one wire we require. Okay, this one wire we require, this one wire we require. Okay, let's first declare the wire. Okay, so this is the 16-bit wire and this is single bit wire. Okay, so we require three wires. So wire. So this is let's give the name as a C out wire. Okay, C out wire. Okay, then another two wires we require. So this is the like 16-bit wire we require because this is like some 15 down to 0 is coming here. So this is like 16-bit vector. They have to mention like slash and 16. Okay, but they're not mentioned. So we have to like assume this like 16-bit vector because like 31 down to 16 we have to fill with this thing. Okay, so total 16 bit we have to fill. So wire 16 down to not 16, 15 down to 0. Okay, so in this we have to connect with the this. Okay, so there we require two wires. So this is inst 2 wire or this is inst 3 wire. Okay, so giving the name as like in that way inst 2 wire and inst 3 wire. Okay, you can give your name according to like your choice, whatever you want. Okay, so for here like I'm just giving this name for this wire. Okay, so after that the instance. Okay, so let's do this instance first. Okay, the name of the module is add 16. Okay, so add 16, the instance name is like inst1. Okay, let's give the inst1. Okay, so inst1 have the like give the parentheses, then using the bracket. So scene is directly connect with the 0. Okay, so dot scene is directly connect with the 0. So directly write with the 0. Okay, so after that we have to see that okay, A and B is connected with the lower bit of A and B. Okay, so dot A is connected with the A, but the lower bit. Okay, 15 down to 0. Okay, so this is connection. Okay, so after that we have to connect B. So dot B is connected with the B, but the lower bit. Okay, so 15 down to 0. So after that, one more signal is remaining. Total four signals are there. So A, okay, C in is coming, A and B is come. Okay, so three signal. Okay, so sum and okay, one more C out signal are also there. Okay, so let's go with first sum and then we are putting C out. Okay, so sum is connected with the sum. Okay, but 15 down to 0. Okay, sum 15 down to 0. Okay, so this 15 down to 0 is written for this sum. Okay, so this sum, don't confuse, this sum is connected with the sum 15 down to 0. Okay, so this is the first instance. Okay, one thing remaining. Okay, so that's C out we have to, because this is the important signal, because which is the select line for this marks. Okay, so this is C out is connect with the whatever the wire we declare, like one wire, one bit wire, C out wire. Okay, so dot C out is connect with the C out wire. Okay, so C out wire, C out underscore wire. So this is the first instance. Okay, just copy paste it. Okay, no need to write again and again the same thing. Just change the like whatever the mapping signal and instance name. Okay, so this is add 16 inst 2. Okay, this is second instance. This is third instance. Okay, let's go with the second instance. Take it. Okay, so C is directly come with the 0. Okay, so no need to change. Okay, here A we have to change that 31 down to 16 is coming, and for B 31 down to 16 is coming. Okay, so that's for A 31 down to 16. Okay, so 31 down to 16. For B 31 down to 16. Let's write 31 down to 16. Okay, for sum same. No, like here is like sum is going to 0 and 1. Okay, so here like we declare the one more wire, like called as what we declare, ins 2 wire. Okay, and ins 3 wire. Okay, so this is ins 2 wire for this sum, ins 3 wire for this sum. Okay, so we have to connect that with the sum. Okay, so directly connection no need, because the same size we have. So let's do with the ins 2 first. Ins 2 wire. Okay, here is 3 wire. Okay, we'll do it later. First, see the C out. What is the status of C out? Okay, C out is ignored. So let's ignore this signal. Okay, and similarly here also C out, they are like ignored. So let's remove this signal. Okay, here but the C in is coming to 1. Okay, here the C in is coming to 0. Okay, so C in is 0. Here let's we have to change in instance 3 1. C in is 1. Okay, so dot A. Okay, so here is like coming the upper address. Okay, so the upper bits are coming. So let's change this to 31 down to 16. Again here like 31 down to 16. Okay, here same thing, 31 down to 16. Okay, so this is thing. If they mention like any connection for C out, at that time we have to connect. Okay, so here like C is connect with the 1, if 1 and 0. Okay, so 0 1. Okay, so we have to implement the that mux part. Okay, so implementation of mux. So what is the mux? Like it's 0 and 1 means like 1 bit mux. So two selects. Okay, so the selection line is C out. Okay, so C out wire would we like declare here. C out wire is the selection line for that. So let's assign for whom we are assigning. Okay, we are assigning to some lower bits. Okay, so assign whom some lower bit, sorry, upper bits, not lower bits, 31 down to 16. Okay, for the upper bits, what we are assigning, whatever the output of the marks. Okay, so let's give the equal sign. So let's use the ternary operator here. Okay, so for that we had how we are like giving the condition, if C out equal to 0, it's come from the second instance wire. Okay, so C out wire equal to C out underscore wire equal to 0, then like not zero, like one tick binary zero. Like good practice. If you go for verification, it's zero, it's okay. But if you're writing RTL, it's better to write one tick binary zero. So if this condition is true, then what we have to do? We have to assign this wire. What is this wire? Inst to wire. Okay. We have to assign inst to wire. Okay. So write that inst underscore to underscore wire. Okay. So this wire is whatever like we declare that wire. Okay. So if this condition is false, what we have to do? We have to go with these wires. Okay. So this wire we have to go. So what is the name of that wire? Is inst underscore tree underscore wire. Okay. So if this condition is false, so it will go to inst3 wire. Okay. So in that way, sum is assigning. Okay. So in this first instance, the lower address sum is assigned. In this, we are assigning to upper address. Okay. Let's submit and check it's working or not. Okay. Some issues are there. Let's resolve that things. Like so A, B, and C in. Okay. So sum is okay, two wire. It went down to 0. Okay. Cities of errors. Okay, okay, got it. We unnecessary like directly assign into some 31 down to 16. So directly can't assign that. Okay. So we have to assign that in three right wire. Okay. So this is the issue here. Instead of connecting to some, you have to connect inst underscore three underscore wire. Okay. So this is the issue for this. Okay. So let's check it. Anything missing? Okay. All things are right. Okay. So just submit and check it working or not. Okay. So there are like some hierarchical connectivity wiring. So let's ignore that warning for as of now. Okay. So we get the status says. Okay. So let's move to our next question. Okay. So this is the I guess yeah last question. Next video we are like seeing the procedure question. Okay. So let's go to this question. So the question is saying that okay, we have to Adder-subtractor we have to implement. Okay. The net result is A plus 0. Okay. Okay. So there's some Wikipedia link. So if you want to see, then you can just go and check it. So modular 16 instantiation they are given that way they have. Okay. So if someone is interested, interested in like position wise connection, so you can go through with that. Okay. So use 32-bit XOR inverter. Okay. Okay, so here is like 32-bit XOR gate inverter. The B input value sub is 1. Okay, so sub value is 1. Okay, so sub is our 1-bit signal. We have to doing XOR operation with the B signal. Okay, then we have to pass it. Okay, so the thing is that, okay, if we like, okay, this is 1 bit. Okay, we can't XOR with the 32-bit. Okay, so we have to use a replication operator here. Okay. So also connect the sub input the okay. So let's implement this thing. Okay. So first we have to do this thing. Okay. So B with the sub. Okay. So that let's do the XOR operation. Okay. So the XOR operation we have to do first. So so first we have to use the keyword assign. Okay. So let's go. assign what we have to assign. Okay, so here there is no signal. Okay, so let's declare one wire like which is 32-bit. So at there we are like assigning it. Okay, or any other way we can do that. Okay, there is no any other way. So we have to declare first wire. Okay, so let's declare wire. Okay, I'm giving the name as like XOR output. Okay, so XOR output, which is this equal to. Okay, here not we are not equal to. Here we are just only declare assign XOR out equal to XOR underscore out equals to. Okay, so we have to do the XOR operation with B signal. Okay, so B XOR with the. Okay, so we have to XOR with the sub, but sub is single bit, so we have to use a replication operator. For replication operator, we are using the flower bracket, or you can say as curly bracket, whatever. So 32 time. Okay, we have to replicate. Okay, so what we have to replicate 32 time? We have to replicate 32 time with sub signal. Okay, so right sub. Okay, sub. This is the like code for the top model. Okay, so this is completed. Okay, so after that, what we have to do from this sub, uh, like lower address is going to this, okay, then higher address to this, okay. So we have to instantiate two different uh, signal, okay, not signal, two different instance of add 16, okay. So let's go to instance. So add 16 inst to 1, okay. So inst 20 inst 1. What are the signals are there, okay? Total 1, 2, 3, 4, 5 signals are there. Okay, scene is connected to sub. Okay, so let's go with this. So dot scene is connected with the sub. Okay, scene is connected with the sub. Then after that, uh, A and B is connected with the. Okay, A is directly connected with the lower bit of A. Okay, so dot A is connected with the lower bit of A, which is like 15 down to 0. Okay, so this is come. Okay, after that we have to connect B. So dot B is connected with the B, then put them down to 0. So after that, we have to connect. It is C out and sum we have to connect. Okay. So first connect the C out. Okay. So C out is connected to. Okay. Here one more 1 bit wire we require, which we have because we have to like pass that value of C out to C. Okay. So I can declare one wire. Okay. So XR out is like okay, one mistake we have done here. Like whatever that. It should be like 32-bit. Okay. So output is like 32-bit. So we have to declare as 31 down to 0. Okay. So in this point, okay. So this wire is like 31 down to 0. Here is like single bit output, C out. Okay. So C out wire, we just give the name C out wire. Okay. There's one semicolon. Okay, so C out is connected with the C out wire underscore wire. Okay. So this is our instance one. Okay. Last signal is remaining sum. Okay. So lower bit sum is going to lower bit sum. Okay. So comma dot sum is connected with the lower bit of sum. The sum 15, 15 down to 0. Okay. So this is the complete. Okay. Total spacing is completed. Okay. Let's go and add the second instance. Okay. So this is our second instance. So here scene is connected with the wire, whatever the C out wire we are like declared here. So same thing. So let's write C out wire, C out underscore wire. So after that, dot A is, let's see. So A is connected with the A upper bit. Okay. So again, I guess we are made one mistake again, I guess, for this. Okay, let's see. Okay. So A is connected with the 31 down to 16. Okay, so B is connected with the, okay, we not directly connect with the 15 down. We are like connecting the output. Okay, so output is C out wire. So we have to, here also we are mistake, C out wire. Okay, so lower bit of C out underscore wire. We have to connect that thing, not C out wire, XOR out, sorry, XOR underscore out. Okay, so we have to connect this XOR out. So here same thing, we have to connect XOR out, not the XOR underscore out. Okay, so 15 down to 0, 15 down to 0. Uh, here like 31 down to 16. Okay, 31 down to 16 because upper address, like this instance for the upper address, 31 down to 16. Okay, so that's why. So C out. Okay, so here C out is neglected. So remove this line. No need. So sum. Okay, so sum is going to 31 down to 16 directly to sum. Okay, so 31 down to 16. Okay, so let's submit and check it. It's working or not, or it's occurring any issues. Okay, some issues are occurring. So okay, so name of the instance. Okay, so this thing we forget to change inst1, inst2. Okay, so just again submit and just run it. It's compiling. Okay, we get the status success. Okay, so in this video we completed this module hierarchy all questions. Okay, so in next video we are like solving this procedure questions. Okay, there are like several questions for the procedures. Okay, so that's for the today video. Let's meet in the next video.